Hello, NASA HUNCH Academy students and teachers. This is the last investigation station that we're going to have for plants in space, and I hope you've enjoyed the first three investigation stations. This one is the most difficult, but it is a lot of fun and very educational. And I'm just going to show you a little bit about it and talk about the engineering design process, because this is really an engineering design process in which you are given certain constraints and you have to meet those constraints in building a plant growth chamber that works in a nanolab. And I don't have a nanolab here, but I do have the base of it, and it even says Nanorax Nanolab made uh, nanolabs, and they still do. And I tried to make a little one for you. I just cut it out of a cardboard box. So you can make a little prototype like this one, or you can just do a drawing and play and place all these different items that we are going to talk about in our engineering design for the plant growth chamber in a nano lab. So the first thing is we have to define the problem. And the problem is to get a lot of items into this small area. And I cut a box to meet those requirements. It's a 4 by 4 inch prism square. So you name a prism by the base, and this is actually the base, and I had the blue is a copy of that. And so it's 4 by 4 and it's 8 inches long. And I just modified a box to fit those dimensions, and I let it open so we could work with it, because if it's really closed, we can't. On the space station, the openings will be on the top, so it won't be cut out like mine is. But our problem is to fit a lot of things so that we can keep plants alive in this little box. And why this little box? Because this little box is hooked up to power and data on the space station in a nanode, it is called, inside of an express rack on the International Space Station. So that's our problem. There's a lot of research to do on this project, because first you need to find out exactly what a nanolab is and how it fits into the space station in the express racks, and then what you would need to keep that plant alive. Now, research is something you do all the time, from the moment you start the project to the moment you finish. And you can assign one person on your team to do most of that research, or you can all do that research, whatever works best for all your students. But you should all know the knowledge of that research. So the person has to be a good communicator and teacher if you're going to learn all the knowledge they get on that. And then every time you have a problem, you need the person to do research more. All right. So the next thing in engineering design is to specify all the constraints or requirements. And this has a lot of constraints and requirements, not just the size, right? There's all kinds of constraints. If this is going in onto space, we can't use glass, and nothing on in this actually now is glass. It has to be powered by a USB connection. Um, Everything has to stay alive, which makes a lot of constraints. You need water, you need air, you need a fan to circulate the air, you need sensors to measure, you need lights, you need a camera, and you need a place to how to store that information. So there's a lot of things you need to do. You should start by listing your things in order of preferences. What is the most important thing you need to do? Is it the constraint of the size, or is it the constraint of uh, the weight, or the electronics of it? And after you list those constraints according to their what you think is the most important, you start brainstorming. And this is so important. I want everybody's brainstorming ideal to be respected and considered. The diversity of ideas is exactly why NASA Hunch hires all of you, because you haven't been trained as engineers. You can think outside the box and be creative. And that's what we want from our students. Be creative, think outside the box. I certainly am not thinking outside the box. So don't do my design. I want something really creative. But I'll explain why I did what I did. And then you take it one step further for me. Um, so you evaluate that. You decide on what ideas are the best, and it could be from 5 different people. Everybody, it's really hard to cooperate and collaborate on this, but everybody's input is important, and you decide ideas from everyone. That's how we actually send things up to the space station. We don't just get the idea from one school. We get it from maybe 5, 6 different schools, and put it together and make a product for the astronauts to enjoy. And then once you develop your plant growth nanolab chamber, then you have to test it. Can plants stay alive in there? And that's where you make sure that all the lights are working, all the watering in the fan and everything is working. Um, that's one of the final steps. So if you don't get to that step, that's okay. I really just want to see how you designed it, and you can design it any way you want. You can design it with make a prototype, you can make a drawing, you can 3D print things. Whatever way you are confident in, that's what we want to see. So once you test it, see if the plant grows, then you actually have to communicate your results. So you have to sell. If everybody in the class is, maybe there's 5 teams, right, making a plant growth chamber, then all 5 teams would present, maybe to parents, to administrators, to school boards, present their ideas, and then maybe again cooperate and come up with a final idea on your plant growth chamber. Or maybe you're going to have to redesign. In engineering, it's the process is design something, test it, redesign it. Design something, test it, redesign it. It's, if it doesn't work the first time, don't consider that a failure. Consider that a learning opportunity, and learn from what failed, and go. If we always think of our our rockets exploding or things not working as failures and quit, we'd never be going to the moon, and Mars and beyond, um, in in uh, in space exploration. So please don't get discouraged. Redesign as needed. Keep doing your research. All right, so I'm going to quickly go over what I kind of did. And so we did send a space, a plant growth chamber in a nanolab. This is a 1.5 unit nanolab to space. I think it was maybe 7 years ago. And we used this board. And this board was specially designed by Texas A&M, the electronics students, and it had all the requirements that we needed for getting the light, the motion, the meters, the camera, and everything, to and the data storage to provide us with information. And um, and the plant growth chamber was called the Hydrofuge, and I have several slides about it because I'm very proud of their work. And they're still working on it at that same school, which is really awesome. Um, and they worked on it for 5 years before it even went to space. And now it's 7 years later, and they're still working on it. So there's resiliency, and there's the engineering design, redesign. But this Nessie board, you see these little things hold micro SD cards, and there's a whole bunch of lights. NASA loves redundancy. So And even with cameras, if you have a camera, I always tell my students make two cameras. I include two cameras. So in case one breaks, the camera is the one that's getting the data. The data will be stored in the mini SD cards and sent down to Houston, where Nanorax has its mission control office, and they can send the data to the schools. If the when the plant growth chamber goes up, then I hope we send another one up. So a few things besides this. This is the electronics. I always want the students to keep the electronics separate from the plant, because the plant needs water, and water and electronics don't mix. So I kind of enclose the plant in a just a plastic container I had in the house. And I'm going to go quickly through the electronics. So this is the electronics that had most of the sensors and the connection on the back there to the power that is in the express rack for these nanolabs. But the important thing I want you to work on is not the electronics really working, but where you're putting everything. You're so confined in space. You have a lot of things to keep that plant alive. And where is the best place to put it? There's motors you can use. There's, I have a little water pump here that the students never used. But they did use some kind of water pumps. Look at the hydrofuge carefully. It has a tear shaped water chamber, because water seems to go to that edge, the angle at the edge, so that it moved in microgravity down. But you can see that I have the plant on the side, because it doesn't matter. It's in microgravity. That plant won't know if it's up or down or or even backwards in microgravity. But see what the research says. If gravity affects the roots and the plant growth, or is it light? I'll let you discover that. So here's my plant chamber, and I just used my tomatosphere plant and cut off some of the pot, so that it would fit nicely in here. And I put this little container in there that is supplying as a mirror. So when I take a picture of my plant, I could see the back of it too, which I want to see as much of the plant as I can with my camera. And these are tiny little cameras. They're really tiny. I don't have a camera, but they kind of look like this. This is the water pump, and this kind of looks like the camera to me too. But I was putting water in here. You never use glass, because glass breaks, and we don't want anything that's frangible. That means it breaks into a lot of little pieces. Glass does. Plastic doesn't. Lexan is good. That's what we usually do. But there's a little syringe, and if you had a motor that could activate it and make this push in and then give it the plant more water this way, it would have to be. But you design what you want. I'm just showing you what I happen to have crazy things at around the house. This is another interesting thing, and I don't know if you've ever worked with Arduino boards, but Arduino boards have been powering our Nanolab experiments up. We've sent several experiments up, and they have been powered by Arduino boards or Raspberry Pis. And you can see on this is called the breadboard, and it has all kinds of lights, and that can make any color, which you need to research that. What color will your plant grow best in? So, but you must, when you put some electronics in here, you must keep it separate from the water. So you make a separate container and just have the lights come out or whatever. And the camera's a problem too. And you have to remember, in microgravity, everything will float. So that's another issue you have when dealing with this plant growth chamber, because you are designing it to work in microgravity. And And so you don't want the soil, you can't have it floating all over. You need some kind of, I think the kids used to use some kind of Gore-Tex that would make it breathable, because the soil or the medium, and you don't have to use soil. Um, think of something interesting. Think outside the box. Will float. Everything will float. So you need a lot of Velcro. And I actually brought a little bit of Velcro up here. You need a lot of Velcro to hold things down in your Nanolab. So that's basically what I wanted to tell you about. And this is the last investigation station on, and you can learn a ton just researching the Arduino board. And I'm sure you will be able to figure out. It's kind of fun because when you do electronics on it, like you see, you can make your lights blink. You can. That's another thing you figure out. Well, how long do I want my lights on? But with that little Arduino board, you can program your lights to turn off and on whenever you want it. And you can program a temperature sensor. You can read data out. So not only will this Nanolab keep your plant alive if you do it correctly, it will also send data on pictures of how your plant is doing. And I think I might have put some pictures of the plants when they were on the hydrofuge up on the space station. Though I'm going to leave you with this one thought, that in the future, I'm really excited that some of the future space stations in low Earth orbit, um, and one in particular that I know of, I think it's called the Star Lab, that NanoRax is working on, and they're now Voyager Space, is called George Washington Carver Park. And that's just for plants. They're making a whole park for plants and hopefully insects too, to grow. Because once we get the plants up, how are we going to pollinate them? Are the astronauts going to have to do that? There's so many questions, but I hope you watched the video where I'm trying to explain why we need to grow plants from seeds in space and can't send food. So thank you all for doing this. I hope you enjoyed the Plants in Space investigation station as much as I have enjoyed talking about them to you. Thank you. Have a good, wonderful school year. Bye.